Hey everybody, this is Stormworks, and I want to talk about vehicle building games. I've got tens of thousands of hours in playing them and another couple tens of thousands of hours in making them. I haven't released any because all of mine suck, but I thought I would talk about what really gets me going and what I think about when I'm making these games, because I don't see it talked about very much. I very rarely see people talk about gameplay of these sorts of games. So let's go ahead and talk about it. Stormworks is interesting because easy mode is really too easy and hard mode is a little too hard. And in both modes, you can really sort of see where I like things and where I don't like things. So it's an excellent way to just demonstrate the sorts of things that I look for in these sorts of games. And it's basically just going to be me rambling for a long time. So if you're into that, pull up a seat and listen. If you're not, sorry. So first things first, this is a game about boats or about spacecraft or whatever, but there's a hull in this case, and the boat hulls have a specific shape to them, and the water interacts with that shape. That's an interesting constraint because it means that the shape you actually give to your boat matters quite a bit. In addition, they've got a center of mass, which is that purple ball, and they've also got a buoyancy, which is just all the empty space inside the boat. These things combine to make building a boat fairly interesting because you have to have a good shape so that it can plow through the waves. You've got to have a good amount of buoyancy so that it can float, and you've got to have a sealed off interior space to keep it buoyant, and you've got to have a good center of mass so that you don't founder. These things are what I would call core physical constraints. These are the things that you have to consider when you are building anything in this game world. Now, if you're not building a boat, you might be building a helicopter or a plane. It's still got these kinds of constraints in mind. I don't think that those constraints are as good in this game because the simulations are a lot less interesting, but it's still a constraint where you have to worry about center of mass and hull shape and all that stuff. Now, in easy mode, that's really all you have to worry about. In easy mode, any module can just be stuck anywhere you want, and the only thing you have to worry about is the weight. So if I were to turn on the cross section here, you can see that there is an engine up here, and there is a rotor back here, and the two have nothing to do with each other. They're just kind of magically separated. And there's nothing else in this. There's no fuel tanks or batteries or pipes. It's just a free-floating engine and a free-floating rotor, because it's in easy mode, which is fine, right? You just plug the stuff in you want, and you make sure the ratios work out, like one engine per rotor or whatever you're doing, right? But here's the thing. This ship will not work unless you configure it, and this one came pre-configured. This is the actual starter ship that they give you when you start easy mode. This one came pre-configured. What's that mean? It means that this part is done. See, if you were just to plug the modules in, nothing would work. You have to tell it that you want to use A and D to steer these specific things. You have to tell it that you want to use W and S to turn the throttle up and down. You have to tell it that you want to use this button to turn the engine on in the first place. Here's the problem. This is a wonderful tool, but it serves no purpose. In easy mode, there is no complexity where I would want to optimize these exact features. There's no situation where I want to be like, well, I want my engines to turn off. I'm never going to want my engines to turn off because I have no fuel requirements, so there's no reason they'd ever turn off. And there's no reason I would ever have to tell these things to be connected to A and D. They are always going to be connected to A and D, right? The only time that would be wrong is if I installed them incorrectly. In games like Kerbal, that sort of thing works automatically. Space Engineers too. You plug stuff in and it automatically configures your controls. The reason that happens is because boilerplate configuration stuff is some of the most boring work imaginable. So you take that boilerplate configuration work away. You have defaults that work out, and then you can allow the players to edit the defaults. Like in Kerbal, you can change the maximum engine thrust or reroute fuel from one pipe to another. And in Space Engineers, you can have engines that turn on and off based on timers and stuff. There's just no reason to do that in here, though, because there's nothing complex enough to require it. But this is easy mode. Let's look at hard mode. Here's a boat I made in hard mode. In hard mode, you have to actually build your own stuff. They don't give you a sample boat. So this is all just raw me trying to get things to work. And it actually works pretty well. So from the inside, you'll notice a small difference. This interior is packed with stuff. So what's going on? Well, the motors and the propellers now have to be connected by a chain of mechanical links. So they can't be separated. Initially, I put the engine in the back of the ship right next to the rotor, but it turns out that that makes the ship too ass heavy, and the ship just won't, it'll founder, it won't go anywhere. So I had to move the engines quite a bit farther forward to move the center of mass forward. I also wanted to make sure that this connection existed, though. I had to run this connection all the way down the back of the ship. The problem with that is there's no dedicated mechanical shaft, so all of these are clutches and gearboxes, because there's no way for me to do it with any sort of dedicated, delicate part. That's just arbitrary. Similarly, the engines have a lot of requirements for intakes and exhausts. So you can see I've got all of these pipes set up, pumping into the engine at various places and doing various things. This one in the front is the intake, which pipes in cool air for both cooling and combustion. And the one on the outside is exhaust, which takes waste fumes from both coolant and fuel burning and just pipes them up through some exhaust ports, as you can see. The one back here that you can see back behind the rest, this is the fuel tanks pipes. And the fuel tank pipes just run down the center of the ship, as you can see, and connect all the fuel tanks to the engine. So the secret is that these fuel tanks actually have a fairly realistic fluid simulation to them. So this looks flat right now, but in the water, the nose is a little higher than the ass. And that means that the fuel tank at the front will actually empty itself much faster than the fuel tank at the back, which means that the nose rises higher and the next fuel tank empties even faster. So I haven't really solved that problem, but I've mitigated it by having a raised fuel tank here in the back, which kind of balances a little bit. It needs more work, but you get the idea, right? I've made a choice to have this fuel tank be higher than the others because of a constraint in how the fuel tanks pump their fluid. So there's a large number of things going on with this. It took me a long time to get it this simple. If you've played this game before, hopefully you are pretty impressed by how simple this entire layout is. It looks a little complicated if you've never played it before, but it is the simplest I could get it. And that's not necessarily bad, but it does mean that the constraints in question are basically solved. And that's not great. So let's talk about the constraints in question, keeping in mind that we still have the constraints of center of mass and hull shape and buoyancy. Within that, with keeping that in mind, we've got one kind of very major constraint, and that's what I call the neighbor constraint. The neighbor constraint is when you have to put pieces next to pieces in order for them to work. So in easy mode, the propeller, it could just run regardless of what it was connected to. But in this mode, it has to be connected via a mechanical chain to some kind of engine. And it might be that the engine's right next to it, or it might be that there's a long list of, stuff between it and the engine, like there is here. Either way, this is a physical constraint requiring specific things to be next to specific things. It's a neighbor constraint. Neighbor constraints are the most popular kind of constraint in this kind of game. For example, all of these pipes are also neighbor constraints, where I have to take fluid in or out of various points on the engine. Now, these pipes are a little bit more freewheeling because they've got T-junctions, so the pipes can be combined and separated at will, whereas with the mechanical linkages, there are, as of yet, no parts that can combine or split them. That's probably just because I have only the starting parts, though. I imagine that there will be that capability later on. Similarly, the fuel tanks are also subject to the same neighbor constraints as the rest of the engine parts, but the fuel tanks are also constrained by a fluid simulation which interacts with the nature of the hull in extremely complex, dense, but easy to understand ways. And it makes it really interesting to figure out the best way to have all of these things work. And unfortunately, I don't have any of the advanced fluid pumps or anything yet, so I am just raw brute forcing it by positioning things, and it's not ideal. But the whole point here is all of these neighbor constraints combine to allow me to create a really, really interesting configuration. In this case, a really, really optimal configuration for the boat. If there were no neighbor constraints, then it would be too easy to create an optimal configuration, or rather, every configuration would be an optimal configuration. If it was any harder than this, then if, for example, there were no ways to extend mechanical linkages, then there would also be no way to create an optimal configuration because there would be only one configuration. So this is a middle ground. You use the neighbor constraints, and then, of course, you don't want to have too many neighbors because it's just a waste of space. But you push it. You push it to whatever your design says. Like other people might be saying, did you really put 3 clutches and a gearbox in there? Well, yeah, I did, because I needed the center of mass to be here rather than back here, and it works great. So with neighbor constraints, you can really push things and stretch things, and it's very interesting and fun. There are a lot of other kinds of constraints here. One of the other constraints is the fluid simulation, which interacts with the neighbor constraint, right? Because all of these are connected via neighbor constraints, but the fluid simulation favors certain ones. And obviously, it's not always a fluid simulation. Anything that causes a specific set of objects that are neighbor constrained to behave differently than their neighbor is this sort of constraint. For example, in Kerbal, you do stacks of fuel tanks, and the topmost fuel tank drains first. This is the same situation as this. So these sorts of constraints these kinds of priority constraints will create a lot of fun pressure to try and figure out the best way to get all of this to work. So now we've got priority constraints and we've got neighbor constraints, and those are the 2 primary constraints when we're building the ship. But they're not the only constraints when we are configuring it. Obviously, aside from the hull and that sort of stuff, we also have the logic. This is a little bit more complicated than the other one, but it's still pretty basic. It looks a lot more complicated than it is because there is a crap ton of dumb boilerplate. For example, all of these clutches here that I use to extend my crankshaft, these all have to be manually set to 1 using a constant number. I have to manually drag the constant number over to each one of them to turn them on, because otherwise no power gets through. The default is 0 for reasons unknown to me. And I can't change what their default is. Similarly, up here, we've got this thing, which is just a constant on, and you can see it connects to a lot of stuff. Why do those things default to off? Why can't I have them default to something else? I mean, it's an indie game, early access, so maybe that sort of thing will become the norm later on. But this kind of boilerplate is pointless. There is no reason for it to exist. Now, we still have the boilerplate from the previous ship, where we have to set up the fins and that sort of stuff to react to our controls. But in this case, there are times when we might want to have other kinds of controls. For example, in the helicopter, there's a gyroscope that you can use as kind of an intermediary. There's also a lot of complexity here in terms of these gearboxes and what they might be able to do. I've played around with them, but it doesn't appear that they are currently allowing for configurations that actually accomplish much on a boat. So right now they're just used to step things physically down, but these are configurable and you can set them up to do a variety of things, as you can see. Similarly, we can have these engines be however we want. Oh, maybe I can make the gearboxes work after all. I'm going to look into that after this session, because that's actually kind of interesting. But there are a lot of things that are configurable, including microcontrollers. You can set up your own microcontrollers. They're not really very micro, though. They're like fist-sized. And put them on your ship and use them for custom interfaces. And this sort of stuff is great if, and only if, your vehicle needs it. So far, the only use I've had for microcontrollers is to check whether a value is below a certain level, and if so, turn on a light. But I can imagine them being useful in doing things like pumping more fuel into the area that is low on fuel, or when I get ballast tanks, maybe I can fill them as I run out of fuel in certain other tanks. That'll be fun, and I'm really looking forward to it. But it only matters because there is a physical constraint that is requiring me to come up with clever designs, and they can facilitate certain designs that are clever but wouldn't be possible if I couldn't kind of nudge things, you see? So putting ballast tanks into this ship just up front and having it so that they automatically fill, well, that would cause me to nosedive and sink to the bottom of the sea. And if I have to manually do it, well, that's a lot of stuff to remember. But I could manually do it. And then I could also create a microcontroller to do it for me, at which point it becomes really nice. And you can see there is that thing there, that hook, where you're like, I want to build a good configuration. I want to push this configuration. I've pushed it. I want to push it more. I've pushed it. I want to push it more. And so every time I say, let me push it more, I want a new part, something that allows me to push it further. I want my bilge pumps. I want to be able to have my ballast up here. I don't have that part yet. I imagine it's in the game, but I don't have it yet. So I can't get any better than this, aside from moving tanks around a little bit more. So, there are a lot of things where I want to push it more, and I'm sure there is a part. I haven't gotten that far in the game yet, though. So I can play it, wait for that part where I can optimize things a little bit more. That's what I live for. I love the idea of, let's push it a little more. Let's make it a little better. Let's take the thing we did before and automate it. Let's take that thing we did before and push it so that it's perfectly balanced. And that's why in Kerbal, one of my fascinations is creating VTOLs. Because in Kerbal, VTOLs are tough, but they are so much fun because it's all a design challenge. And that's what I really love in my vehicle design games. I don't like numbers. I don't like saying, well, this thing needs to have, 80 power points in order to fuel the 70 lasers you put on. That sort of thing isn't interesting to me. It's all about topological configurations for me. And I really do appreciate when a game allows me to really cut loose and create these kinds of topological fun and games. This boat actually runs really well. I can go ahead and show you. It runs really well for a starter boat. After about 8 kilometers, it starts to nose up, which is unfortunate. I have to do some more configuration work to make it work out there. But as you can see, it for a boat that is nothing but starter parts, it hauls all sorts of nice little ass, doesn't it? And it doesn't flip. Not until after 7 or 8 kilometers and the fuel gets low. Nice. Boom. Oh no, I broke it. So, this is some of the things I like to think about. Now, when we talk about hull constraints, you just saw me break the ship a little bit. I damaged the front end a little bit. Hull constraints of the sort that are damage, those are interesting because they're not usually done right. I don't know whether this one does it right or not because it's actually very hard to damage your boats. But I know that Space Engineers does it very badly, for example. When you're taking damage, there are a couple of ways to think about it. One is entirely local, like Space Engineers. So if you hit a rock in Space Engineers, the part of your hull that hits the rock gets damaged, and that's it. And this means that if you get shot full of holes via missiles or whatever, you're probably still going to be fine because your ships in Space Engineers have a ridiculous amount of redundancy. There's very, very little in the way of neighbor constraints. So, they're not going to blow every single one of your batteries away. You'll still have your engines. It'll still work out fine. At worst, you'll lose hydrogen engines. So in that sort of game, getting damaged is not really enough of a constraint. I did a lot of extensive research on this, if you believe that. The only kind of armor that matters in Space Engineers is how you layer it for combat so that your weapons remain intact. Nothing else matters. Just you want your weapons to remain intact. And that's the only part of your armor that actually matters. Another method of doing damage is to do it with numbers. So, if you're playing Star Trek Online, then you have N shield points, and they go down. And once you start getting hit, you start taking damage. Now, there is some topology there. You have forward shields and aft shields and left shields and right shields. But there's no magic topology. There's nothing I, as the player, can really do to make those engines interesting, or those shields interesting. All I can really do is choose whether they're strong or weak. But there is another kind of damage that we don't see, and it's related, the reason we don't see it is related to the reason that we are always seeing these voxel games. I do not think that voxels are a good match for vehicle games. I don't think that vehicle games should use voxels. I'll explain why they do in a minute if you haven't figured it out. But the problem with voxels is that they are really hard to do physics to. It's hard to simulate physics on a voxel. Now, in this case, we've got some simulation in terms of the faces of the voxels hitting the water, and they've done a very nice job of really optimizing that and having it be pretty fast. But here's the thing. If I actually hit something with the nose of the ship here, speaking as someone that's run a lot of crap into other crap, yeah, sure, the nose gets damaged, but you know what also happens? Right here, it cracks open. And that's because the structural elements of the boat are not along the hull. The structural elements of the boat involve a skeleton structure inside the hull, and the hull is just a paper wrapper around it. So when you hit something with the hull, you're either punching through paper or you're striking a core structural beam that is connected to other core structural elements all throughout the ship. And this is why in Star Trek, you get hit by a missile and your monitor explodes. It's like, oh, that's so dumb. Well, yeah, it's dumb, but that's also more realistic than it not happening. We've gotten too used to this idea where if you get, oh no, Deck 3 got hit with a missile. I guess Deck 3 is damaged now. It's 18% damaged. No, there's a shockwave running through your ship, ripping apart your electronics and venting your precious, precious space juice into deep space. So that's the sort of damage that I like when I'm trying. That's the reason most of my vehicle games never really got published, because it's actually quite hard to do that. But if you're talking about constraints and you're talking about damage, you have to consider what you mean by damage and what that actually means. And I know that my opinion is a minority here. Most people are quite happy with the basic kinds of damage that you see. And I just think that it's a shame, because it doesn't really let you have a topological damage response. I can't put in a thicker beam to have it be more damage resistant. I can't move the beam a little bit. I can't put in a crumple zone. These things don't make any sense because the damage model doesn't allow them to. And this is exactly the same thing that we were talking about before. It only matters if your underlying structure makes it matter. So, if your engines and your propellers don't have to be connected, then their position doesn't matter. But the instant that they do have to be connected, their positions do matter. Same with damage. Without anything that actually propagates the damage properly, there's no reason to really worry about it much. Now, there were a couple of other things I wanted to talk about. Let's talk about voxels. So one of the big reasons that voxels are popular is because it's very easy to create these multi-voxel objects, like fuel tanks, engines. These sorts of things are not a voxel. They're like 3x2x2 or whatever. These are fun. Every game that uses voxels does this. Space Engineers does it as well. You just have these large, chunky pieces that you put into a voxel grid, and then you can use smaller objects to form connections between them, like these voxel pipes. I don't think that's a bad idea. I just don't like it for hull. And one part of that is what I talked about before. You can't propagate damage through voxels very well. It takes a lot of effort to determine whether this is a contained space. And even if there is damage, it takes a lot of effort to determine whether the damage is going to ripple back and cause a rupture here. So because of that, I don't think that voxels make for a very good hull. And there's really no excuse for continuing to use voxels for hull. It takes a lot of effort to put voxels down and to shape them. You have no idea how long it took me to make these frigging 45-degree planes here. This plane took a lot of effort because I have to sit there and painstakingly put in every single set of blocks over and over and over like this. You're like, okay, well, I got to make it line up. So what's the lineup button? Yeah, there we are. And then I got to do the next one, and it's like and it's just like, seriously, that's how you're going to make me do the entire nose? And it's really hyper limited because it's all 45-degree angles due to the optimizations in the physics engine. At least that's why I assume that's why it is. And Space Engineers used to be like that too, but since Space Engineers doesn't give a shit about physics, you can just put in any old size block you like, and now 1x2s are just as common as 1x1s. Either way, this boat doesn't need to be simulated like this. Now, I'm not saying that Stormworks needs to change. This is fairly far along its development path, and I think it's going to be fine the way it is. But for me, what I really love is being able to adjust the values and then have the whole build itself as a mathematical setup. So for example, you put in like a bow, a metal bow that runs from this pipe here around the front and back to that pipe there. And then it understands that that's an anchor point for the hull. And then you run another bow down here, and you can adjust how deep the bow is and how fast it curves and that sort of value. And then it can just automatically fill in the ribs and then put the skin on. Because that's stuff that you can do mathematically. I know it's stuff you can do mathematically because I've done it. I've done it in dozens of prototypes, which doesn't sound impressive because they're prototypes, but it is possible. And then once you have a mathematical constraint, the simulation suddenly becomes much easier because you're working with math rather than with an actual, like, endless array of physical objects. And that means that you can do a lot of really, really nice stuff. For example, in a boat simulation, you can have, instead of these high-sided boats with this corner here, which is what you see in almost all of these boat building games, you could have a slope that starts pretty vertical and then swims around down to a point at the bottom. And you can adjust that to make it as barrel-bellied or flat as you'd like. And that sort of thing can radically change how the boat sits in the water in a way that's much easier for the player to understand. Because I have no frigging idea how this boat sits in the water. I don't have this. The water simulation is not visible to me. I don't see like vectors or anything. It would be much more simple if you could see it as part of the mathematical model. It builds the mathematical hull around your ship for you, and then you can just press a button over here, like a wind tunnel button, and it'll show you how the flow works. That's something that's not that hard to do if you're doing it with math. You could also do that with water, in this particular case, with the voxels. And that's something I kind of would like to see. But again, you would be looking at a simulation where every single one of these little voxel pixels, every single one of these voxels, has their own part to play in that simulation, and their own part to play is excruciatingly limited because they're all 45-degree angles. There is less and less reason for us to continue to use structural voxels like this. The number of things that these are actually valuable for is quite limited. Just as with pixels, there are artistic uses for these. I've seen a lot of games recently that have used voxels in amazingly artistic manners. But for simulating things, voxels really, they aren't the best. Math is better, and math is also looks easier. It looks graceful. It's easier to modify. So that's the sort of thing I'd like to see. Now, if you look at the works I've been working on recently with my shipbuilding games, I've actually gone in the exact opposite direction, and I'm not using anything even vaguely related to this. But in my previous game, which Unity 8, I was using a setup where you were building the crew elements of your ship, and it was very voxely, in that every single one of the crew elements was a large-scale voxel, like a 4x4x4 meter voxel. And what I was doing is I was allowing you to basically use neighbor logic to program it and create programming elements. And that was that seemed like it would be kind of fun, but it was also a little hard to communicate with the player as to what was going on and why they needed to do it. I might tackle it again later after I get over Unity destroying it. But what I'm doing now is a much more basic simulation where you choose the systems that you've got in a very story-like manner rather than in a physics manner. But the actual ship design that I'm using is quite a bit different from this. Rather than having the hulls be defined as voxels or as specific modules, the hulls mathematically grow and extend and shrink depending on what modules you've got installed, and the shape of the ship will morph depending on what you've got installed where. And that's a much deeper sort of expansion and contraction than just adding in another layer of voxels. It's still very simplistic. It's not something that's difficult, but it's something which I think gives a much better sense of you customizing your ship. When you add a module in and you see the profile of your ship change because you've added that module in, and if you add a different module in, you see your profile change in a different way, and you can do that without having to manually specify, oh, I want, these 85 pixels here to be hull elements. You don't have to do that because that's the boring part. Similarly, you don't have to do this because this is the boring part. I'm really looking forward to when it's not the boring part, but you have to have the underlying constraints make it interesting. And at this point, they're not there because I'm using starting parts. So there's a lot of this boilerplate stuff, and that's something I've been working very hard to avoid in my current game. The boilerplate stuff is really interesting in my current game because if you assign a system, you're allowed to assign a new subsystem to any system in the ship, even if it's not very compatible. So for example, you can take your chemical tanks and you can put them on the rocket engine. That makes sense, and they perform very well there. Or you can take them and put them on your support system, where they help to power your shields or whatever, but they don't really perform as well. They produce a much worse effect, a much lower boost to your support. But later on, if you need them as engines, you can go and redirect them and make them into engines. And that is a very, techno-babble Star Trek sort of feel, but it's also this. It's this. I am allowing the player to set up a fallback mechanism, to set up a customized thing where they're pushing their design a little bit further because they can go in and later on during the mission they can adjust it so that it does something different when they need it to. And of course you can't go the opposite direction. The fuel tanks are associated with the rocket engines, so if they're on the rocket engines, they stay there. But if they're on something else, you can always redirect them. And I think that sort of fallback is hopefully a good replacement for this. Now, the underlying simulation is much simpler in that game because it's a story-centric game in terms of it creates narratives rather than creating simulations. But the basic core pieces are still there. It's just a different focus. I still have the neighbor constraints and that sort of stuff. It's just on a level that is much less voxely, and it's much more chunky. And I'm hoping that it's going to be interesting, but who knows? It might suck. All the other ones have. Anyway, this game is Stormworks. If you like this sort of game, you can go pick it up on Steam. It might be somewhere available somewhere else too. I don't know. There are a ton of games like this. Feel free to tell me your favorites because I am curious to know why you like the games you like. One thing I didn't mention, I think that it's important for your vehicles to have fitness tests. In most games, that would be missions to accomplish. I don't like building vehicles for missions. Like, I don't want to see mission A and go, I need to build a vehicle specifically for mission A. But I do want to have a vehicle and then see mission A and go, my vehicle can do that mission. Because that's a fitness test. It's really, really nice. Some games are too mission free and some games are too mission strict, but that's another discussion entirely. I think I'll leave it here. I've been babbling on for a long ass time. And if you're still here, thanks for watching.